let's start. I add a new Nodal Displacement modifier. I just pull this over here and just a moment. Okay, so the first thing we want to do is to push outward these pieces in a radial fashion. And in order to do that, we need to define the vector which displaces these pieces. And for this purpose, the best solution is, I guess, using the mesh part center info, because if we add part center position to every point in the mesh, then it will move pieces outward, but we may want to leave the z-axis out of the game, because we don't want to displace parts on the z-axis. So let's add a transform node, plug it into the input, and we also need this vector scalar node so we can deconstruct the part center information. Let's copy paste this. Just let's set it quickly to Y channel, and now we are making a make vector node. And that's it. Okay, now we have successfully displaced the pieces outward, but just for the sake of this tutorial, I show you what happens if we use part center as it is. You see the displacement happens along the z-axis as well, and we don't want that. All right, let's move forward, and I just add a turbulent noise to this setup because I want to modulate or turbulate this amount of displacement. And from a previous tutorial, it may seem familiar, this using this vector scale node. So let's use the alpha output. Okay, it's pretty ugly because we have to compensate this thing. We have to tell the points that they take texture value per piece from the same texture coordinate, and that's a bit wonky, but you always have to do this if you are dealing with procedural textures that you subtract from point position, or in this case object position, the part center, and you plug it into the position input. And now of course with dpkit you don't have to mess around with this subtraction, but when you are using the native deform nodes, you have to always do this. So it's pretty okay, but still a bit uniform, and I want to rotate these pieces a bit. So let's we need to define the rotation axis, constant vector. Okay, this is going to be our rotation axis, and let's just zero out x and y and leave z as 1. And the rotation angle can be the noise output, but it's not very visible still. So I just tested it previously. I add a random scalar function and I feed, first no, I add the multiply, scalar multiply node, and I will multiply the random value with this alpha, okay, and I plug it into the rotation, so we have a randomized rotation which is somewhat odd but could be better. And as you see, we have this seed input, the random scalar. So what if we use the part index, which means each time the random function is invoked, it uses the part index as a seed, so it produces different random values, and it's much better than this uniform slight random. Okay, so we have now this randomized rotation, and if you want to increase, if you want even more rotation, then you have to copy paste this multiply node, and let's set it to 3, so we multiply the result by 3, so we have a bigger amount of rotation. When it was set to 1, originally it's set to 1, so with 3 it's bigger, and okay, it's okay, but we also want to have the fade effect. So let's add a gradient curve node. This may seem familiar from previous tutorials. This is a very handy node. Let's dive in. We are going to use the z coordinate of the points, and we also are using the alpha channel. So let's set it up. This is going to be -6, and the value is going to be 0. And it means that any point incoming vertex will get a alpha value based on this curve. So if the incoming point has a z coordinate of -2, then it will get a alpha value of 0. Something like A70 or something, and this value can be used for various effect. So let's drive this translation vector by another vector scale, so you see what I'm talking about, and you don't see anything because there is no vertex information in this zone. Let's shift this over the positive side. Okay, now you see. Okay, so if we just set keyframe on this and this guy, just a moment, I rename this curve because there are quite a few curves already in my setup. So let's right click rename, and I name it like something like fade. Okay, and now if we go into the envelope, you can easily select this curve from here, otherwise it would be something else. So now we have the two keyframes, and just right click and control right click and pull it aside. Okay, and I just with the left mouse button I push these guys up. So now we see the animation. but it's not enough. We have to push more, just like yeah. And also we can use this fade value to zero out the rotation angle, and we need another multiply. We multiply a lot, and okay, so now if we play back the animation, the rotation as well zeroes out. Okay, just a moment, just to have a better look. Now they nicely rotate back, and they regain, the pieces regain their original position and rotation. Also, what can we do more? I think this should be enough for this setup. It's pretty complex already. So let's add another modifier, and let's set up the stretch. So I will add a deform stretch node. I plug it here. Set mode to set, and we need to define effect center. In this case, if we want to have the stretch happening around the part centers, we need to define or add another mesh part node. So let's plug part center into effect center, and stretch is going to be the previously created fade, because that can be reused. It would be nice if we shouldn't copy paste these nodes from one editor to the other, because now this is an independent editor, and if I change this here, in the other editor it will not change, but we have to live with this attribute. So let's create out of this alpha a vector, because the stretch is a vectorial value. So let's make a vector, make vector stretch, and plug all the alpha values into the inputs, and if we play it back, heck, it's way too slow, you see. But this is not the effect we want. We want the reverse. So let's invert this alpha value. It's just a simple invert node, and do this. Okay, now the pieces appear from nothing, from the void, and slowly but steadily they regain their original state. Okay, very simple. If you want more bigger amplitude on the translation, you can do that easily. Just let's copy paste this multiply, and multiply the fade value for the translation by a bigger number, something like maybe 5. And also you may notice that now the piece, I want to fix this. Now you see these pieces are distorted, and you may want to have a stepped effect. Okay, and that's very simple and easy to do. Let's just copy these vector scalar values nodes, and let's use the Z channel and plug it into the input of this fade, and plug the part center here. This tells the vertices in the mesh that or rather this fade function, that for every point being evaluated, by this curve node will receive or will have an output alpha value based on the Z channel of the part center, which is uniform per piece. Every piece has a uniform part center, so every point per piece shares the same part center Z value. So whenever the points are evaluated in this setup, the same the vertices belonging to one part will be evaluated by this part center Z channel. So that's why the step. Otherwise it looks like this. Okay. All right. Now there is one more thing. We have to define the twist. I already have two nulls, and I just quickly make another nodal displacement, and I add a deform twist node to the setup. Set this to set, and we need two item info I say, in order to access the null information. Okay, so set the first info node to vortex base, the second to vortex handle, and plug position from the first to base control, from the second to effect handle control. And let's define the axis. It's just a simple constant vector. Heck. And that's going to be a 0, 0, 1 vector. So it points along the z-axis, and the amount of twist, you can either define it by using a simple scalar, but I prefer using the bank channel of this null. So let's extract that information by adding a vector scalar node, which is familiar already, and use, instead of maximum, the Z channel. So this, okay, and that's it. Of course, if this rotation here is set to 0, you can do whatever. If you just move around these guys, nothing happens. So it's pretty important to have this rotated, so by some degree, okay? Otherwise there is no effect. And also keep this other null close to the center line, because if you pull this aside, you see the effect goes quite dramatically, or becomes very crazy. So you can do these things. I don't know for what purpose, but you may find this interesting. All right. And also, if you pull this guy and the other, you see the effect happens between the two nulls. But it's you have to set this up carefully. It's quite sensitive. But basically that's it. This is the effect we wanted in the first place. So let's just replay it one more time. Yeah, you can replace the twist with a bone structure, for example, for better control. But I just wanted to include the twist deformer. So I hope this was useful, and thanks for watching. See you in the next video. Cheers and bye.